We came down from Louisville, Kentucky area to do this. I've been doing Python since 2008, about the time that Google App Engine came out. I was doing PHP. I had been doing PHP for about 4 years. I was filing bugs more frequently than I would like to, bug reports. I was having bug reports for legitimate bugs get closed more frequently than I would like. I actually had a bug relating to PHP creates these session files and for the cookies. And there's a special way to, when you set the path in the PHP.ini file where you want those cookies to be saved, you can put a Unix mode string in there, you know, like 666 or 777 or whatever, and a semicolon, and then the actual path. And I was doing that, and it wasn't working, and so I filed a bug report. And the guy closing the bug report said that's not a feature of PHP. They don't let you reopen bug reports. So I had to go to a different bug report, point to the old bug report, and say it's documented in your PHP.ini file. That was the first straw. The second straw was a bug report in the DBI layer, and there was an issue with inconsistency between the way two drivers were doing things. And they said, we're not trying to hide these inconsistencies. It's a problem with the underlying database. You're just gonna have to work around it. And I'm like, but the function doesn't even work the way that the documentation says the function should work. It's like you're saying you're saying it's supposed to do something, but it's not. And so I was getting frustrated with PHP, and Google came out with App Engine, and I was looking at different, like, what else could I possibly use? And you know, in that era, you know, Django was pre 1.0. People had been using Python, like you had Zope and stuff, you know, they were out there, but I didn't know anybody who used anything like that. Plone. But really, Python in the web world at that point in time was just kind of starting. You didn't even have Pyramid, what was it? It was Pylons back then, I think, or something like that. And Flask wasn't around. Cherry Pie, I think, was around. But it was pretty interesting landscape. You know, Ruby on Rails had a pretty good user community. And when I looked at Python, it just seemed like such a better engineered language. I tried Ruby, and it was like, I don't know, the whole, I forget what they're called now. Are they called generators? It's that weird looping syntax. Blocks. For some reason, blocks did not sit well with me. And they were all over the place. So I would have much rather had the bigger community of Ruby on Rails, but I dug in. I created my own framework, which only we use, called Blaze Web. I pulled a lot from Pylons at the time, and it took me about a year. I have one or two websites that I built back in that initial year, and I cringe every time I have to go back and work on them because of how bad they were. But it's gotten a lot better from there. My name is rsyring. I am Chief Executive Developer of Level 12. You can get the Bitbucket repo. This is a IPython notebook, and there's also some HTML slides there, I think. I'm going to go ahead and get started here. I own Level 12 Technologies. I'm a partner of Level 12 Technologies. We are a web and database development shop that uses solid engineering, proactive communication, and modern development practices to make our customers really, really happy. They don't know they're happy. All they know is that their stuff's working, and they can be upset about other things. But trust me, they're really, really happy compared to a lot of the other stuff that I've seen out there. Okay, so date and time. The big issue here is that it's confusing. Not everyone uses the same calendar. We have leap years and leap seconds that we need to consider. The main thing that we're going to talk about today is time zones and daylight savings time, and how we have different representations of the same moment in time, the same instant of time, and there's even different time standards. How many people thought that UTC and GMT were the same thing? They're not. Technically, they're not. For all intents and purposes, for our time in these days, you can consider them equal normally, but technically there is a difference. So, as I started to do research for this, I was telling some of the people that were here earlier, I actually thought this was going to be just kind of a real quick talk about some of the problems and then show the libraries. I really wanted to demonstrate some of the libraries that I've found that have been helpful. What I realized is that there really is this big mess that I just, for all intents and purposes, I had glossed over. And I think it's okay to do if you follow best practices. And so that's where I'm going to end up. If you're interested in learning more, if you have you're thinking about building a application that's very time sensitive, you're going to need to know a lot more than obviously what this presentation is going to tell you. There's some links here to some really good videos and documentation that goes into the details. This one, PyCon 2013, Blame It on Caesar. He actually does an amazing job of kind of going through and documenting historically like all the weird things that have happened, and it's kind of interesting. He kind of doesn't get to Python for about a half an hour, but it's an interesting talk if you'd like to know more about some of the weird inconsistencies in history. And then there's a couple other links there for that aren't videos, that are just docs that you could read in articles. So in an effort to shoot for clarity here, we need to kind of set up some terms and make sure that we're all on the same page about what we're talking about. So an instant is an infinitesimal moment in our time continuum, a moment whose passage is instantaneous. So it's really this time instant that everybody is trying to get at, right? When I say let's have lunch at 1 o'clock p.m., if I say that in this, we know what 1 o'clock p.m. is because we're in the context of the time zone that we're in. But that particular moment in time, that 1 o'clock p.m. our time comes around, all kinds of other people have different labels for that same instant in time. So our goal is to represent and manipulate instants in a way that is meaningful to computers, so we can do stuff for people, and meaningful to humans, so that once we've done our stuff, they actually know what we're talking about. And it's really that translation that is most of the problem. So the Gregorian calendar and UTC is the modern time standard. Therefore, the authoritative representation for my talk of an instant will be UTC time. Maximum precision will be the second. We will use the ISO 8601 format. Therefore, or Neil Armstrong stepped onto the moon for the first time on July 21st, 1969 at 2:56 a.m. UTC. Therefore, in this presentation, we would represent that particular instant in time as the string 1969-07-21, 02-56-15Z, the Z being the designation for the UTC time zone, among other designations. That the format's a little bit flexible. That's what I'm going to use. Any questions about any of that so far? If you have questions along the way, please interrupt me. I like to be a little bit more dialogue-oriented, but I feel like I'm going to run out of time here. But if you have a question or a comment, please raise your hand. Humans don't like UTC. If I tell you, hey, let's go have lunch at 1 o'clock, offset 0730 negative, like, what? And so that just doesn't help us. The other issue is that it's not always clear why certain people have time zones the way that they do. Some people have offsets that are equal. Some people change due to daylight savings time. There was actually, I was doing some research in it, there was one time zone that for a while had midnight be when the sun rose. So every day they had a different time zone. So it's really weird. Because humans don't like UTC and we rarely refer to date times with a specific offset in mind, it leads to ambiguity. 1:27 a.m. my time might refer to a time that you call 3:42 a.m. UTC offsets can be added to remove the ambiguity, but UTC offsets change based on geographical location and time of year. So I might, my offset right now might be, what is it right now? Anybody know for Central? We're in Central Standard Time? -6. Okay, so we're -6 right now.
Yeah, it's -5.
It's -5 right now? Okay, so if I'm -5 right now, and I say, let's have lunch at 1 o'clock p.m. on October 5th, which is past the daylight savings time, which offset am I using, right? I could specify it right now. I would say -5, But if I want to do it then, I would actually have to say -6, and I would have to mentally adjust and know that daylight savings time is going to change. Nobody wants to do times and appointments this way. The interesting thing about time zones is that they are geographical regions. So time zones are geographical regions that are using the same rules to offset their local time from UTC. So here's some examples. So this is in UTC time, 8:59 a.m., right, on March 3rd, 2009. At this same moment in time in Denver, we are at a -7 offset. We go 1 minute more, 1 second more in our time continuum. We have 1 second in UTC, but we have a 1 hour and 1 second difference in the local time. Why? Daylight savings time, right? So daylight savings time switched here. Phoenix, for the exact same UTC time, agreed with Denver in a -7 offset. 1 second later, they are now an hour different from Denver. Fun, right? Okay, what are the implications from this? Knowing a geopolitical time zone only gives me an offset at a specific instance in time. So I have to know the time zone, and I have to know that particular time reference before I can tell you an offset. Knowing that I'm in the Eastern time zone, or right now the Central time zone, U.S. Central, it doesn't tell me what offset you're going to be at. It could be -5, it could be -6. Tomorrow, Congress could pass a law. I guess that Congress and the Senate would need to, and Obama would need to prove it, but you get the point. So they could pass a law tomorrow that the entire United States, that all time zones are going to now be UTC. So tomorrow, our UTC offset would be 0. And that could theoretically happen. And so as computer programmers, we need to be mindful of the fact that these differences. So,
but also, as you're pointing out with your example, the time zone isn't enough because certain states don't, or in certain parts of states don't respect it. I lived in Arizona, and so we had this issue where the rest of the world switched twice a year.
So the time zone is enough if you know the particular time, instant of time that you're referring to, and you have a time zone database that tells you the rules. So, and we're going to get there. So not only do you have DST, but you have this whole political thing going on here. So in 1915, Warsaw switched their time zone. At this UTC time, it was 11:59 p.m. in Warsaw. They were plus 124. That's fun, right? 1 second later, because of a political decision, they adjusted their time zone. So at midnight on this day, everybody rolled back their clocks 24 minutes. And so now, 1 second later, their offset is +1 hour. So this happens in other locations and to other countries and in more modern contexts. The implication here is that offsets can be arbitrary. They do not have to be multiples of time, although right now they're all at least in 15-minute increments. I looked it up on Wikipedia, which is always reliable. It's close enough, and it's, at least right now it seems as though everything's in 15-minute increments. But you know what? It doesn't matter for us because we don't want to keep track of that stuff by ourselves anyway. The end result here, and this wasn't so clear to me until I did all this research, there isn't an algorithmic solution for converting time zones to offsets. It's not an algorithm thing. It's you just have to know the time zone, and you have to know the rules that were in effect at that particular moment that you're trying to do time zone conversions. So time zones are geopolitical designations and do not by themselves give us a time offset. Time zone offsets can and do change over time due to the political process. Some time zones use daylight savings time, which alters the offset during the year. A time zone at a given instant in time can be used to find its offset to UTC if a database of time zones or offset mappings is available. And that database must take into account both historical, geopolitical changes and must take into account daylight savings time. enter the TZ database. In my research, apparently there's one other one that I saw reference to, but it's in Java, and there's no C interface. So the data's there, but it's hard to get at. And I only heard it in reference on one of the PyCon talks when there was a commenter that talked about it. So this database is referred to as multiple names. The one that I frequently hear in the research was the Olson database. Although when I looked it up on Wikipedia, they said that that's kind of an old name, and they're trying to move away from that because apparently Olson, which is the guy that started it, is no longer the primary maintainer. It defines time zone naming conventions like America, New York, and Europe, Paris. It has recorded historical time zones in all civil changes since 1970. But I saw some examples of the Warsaw thing using that time zone, so I wonder if maybe it has some stuff before 1970. I'm not sure. It includes transitions such as daylight savings time, and it also records leap seconds. So actually, that's interesting. Did you know that in some instances you can actually have a legitimate timestamp that has a 60 at the end? It represents a leap second. Who would have thought? Teach you to use a regex to parse that, right? Yeah, okay. All right, so Python TZ data libraries. Python itself punts when it comes to supporting time zones. The docs say that supporting time zones, this is the Python docs in the date time module, say that supporting time zones at whatever level of detail is required is up to the application. The rules for time adjustment across the world are more political than rational, which I think we've demonstrated, and there is no standard suitable for every application. The reality is no application developer wants to maintain this database. It's too hard. There's too many things going on. And so that's why we have the libraries like the TZ data library. Python access to this library comes primarily through two packages that you can find on PyPy. The first one is PyTZ, and I had to put that pronunciation in there because I would call it PyTZ. The nice thing about this is that it's frequently updated. Anytime the time zones change, they throw a release out, as far as I'm aware. That can be a little bit frustrating if you have to always update that, but if you're relying on, if you have an application that's very time zone sensitive, then you can get frequent updates. Unfortunately, from what I understand, that library does not take into account any TZ data databases that are at the OS level. It only uses the one that's compiled into it. The Python dateutils library is less frequently updated, but it can use the OS level TZ data. So choose wisely based on your needs and with those understandings. And if your app is time zone sensitive, make sure that TZ data is updated regularly. You might wonder why would you use Python dateutils? Why would the OS level library matter? It seems like that would get stale sooner. The reality is that your distribution, or maybe you've got some sysadmins who are doing a really good job of keeping those libraries updated on your systems. So it may be that it's easier to update that in your situation than it is to update the application's libraries. So that might be a reason why you'd want to use the time zones from dateutils over PyTZ. So all of this, once you understand all the problems that can crop up, there's basically a couple best practices that we can use to remove most of the problems here. And if we stick to these best practices, it should be pretty easy to reliably work with date times. The first best practice is to always measure, calculate, and store time in UTC. The local or ambiguous user or client input should be converted to UTC as soon as possible. So if you have somebody who makes an appointment on your calendar app and they put it at 1 p.m., you need to understand what time zone they're in, and you should convert that to UTC at the very edge of your application as soon as possible. You need to be prepared to handle local times that don't exist or occur twice. So if a daylight savings time user asks to schedule a meeting on March 9th at 2:30 a.m. local time in the United States, what's the problem with this? That's the leap year day, or the DST changeover. It happens at 2 a.m. So what happens at 2 a.m. in the spring?
Spring's forward.
It becomes 3 o'clock. So what do I do if a user asks me to schedule a time at 2:30 a.m. in local time? It doesn't exist for them. They're asking me to schedule a time that doesn't exist. So I tried this in Google Calendar, right? Because I thought Google's got to have this right, and they actually they bumped me to 3:30 automatically. You have the same problem in the fall. What if a DST user asks to schedule a meeting at 1:30 a.m. local time? Well, what's the problem in the fall with 1:30 a.m.?
Fall back.
It happens twice, right? Google assumed the current offset. So in Google's world, I would have had that appointment at the first 1:30 a.m., not the second one. It seems, you know, after I thought about this, it seems like legitimate ways to handle it. But you got to be aware of this, right, as you're dealing with these local time to UTC conversions. Once again, when you're converting from UTC to local time for presentation, do that as close to the client or user as possible. The key thing here is if you're not sure if this is legitimate, make sure you have a feedback loop in your input to, if you can, right? If you're parsing log files, you're kind of stuck if they're in local time, right? You can't, there's no feedback loop, you just got to guess. But if you're actually getting input from a user, be mindful of the fact that you can ask them to clarify if it's an ambiguous situation. If any of you are familiar with handling Unicode and bytes, this is the same paradigm. If your user or your client application is giving you bytes, convert to Unicode as soon as you can on the edge of your application. Internally handle and store Unicode and do all your manipulation on Unicode. And then if you need to convert to bytes, do that at the very outside edge of your application. And so it's the same paradigm. Best practice number 2 is to internally always use offset naive datetime objects and consider them UTC. So Python datetime objects come in 2 versions, time zone aware and time zone naive. Python's API for working with time zones is limited and sometimes actually broken. Be mindful of the fact that now methods all return time zone naive objects. So even if you do a datetime .utc now, you're not going to get a time zone aware object. It would make sense to. It would make sense to have that be the UTC time zone. But that's not how it works. And because of these inconsistencies and bugs, everybody recommends that you convert on the edge to UTC, and then all your date time objects should be time zone naive. So if you have a date time in your application, you should be able to assume it does not have a time zone info associated with it, and it represents UTC. That's the goal. So just to give you an example of brokenness, PyTZ gives us time zones that we want to use. And we're going to pick this particular moment in time here, and we're going to give it a UTC time. And then we're going to take another time, and we're going to convert it to Italy time. And so if I print my string, and I do a string format time, which gives me the POSIX timestamp, you'll see that this is my UTC time. It's +0, and this is my timestamp. My Italy time is a different time, but the same when you consider the offset, right? So it represents the same moment in time. It's 2 hours later, but we have +2, so we recognize this is the same time. But when you convert to a timestamp, a POSIX timestamp, it's different. So it's broken. Don't use it. The other thing you have to do when you're doing this is pay very close attention to the methods that you use when you're creating time objects. If you make the assumption that all your stuff is going to be UTC time, and then you call datetime.now, you're going to end up with a local time. Make sure that you're calling UTC now instead of .now. That's a big difference, right? You don't want your user to get to their meeting 6 hours late, 5 hours late. Okay. Oh, so this is another set of methods where you have to be careful about what you're using. POSIX timestamp is UTC. Everybody knew that, right? Should be if your system time is set correctly and your time zone is set correctly. Date time from timestamp makes sense, right? I got a timestamp. Let's turn it into. I have a POSIX timestamp. POSIX, right? Is it POSIX? POSIX. POSIX. POSIX timestamp, I want to get a Python datetime object because that's what my database needs. And so I convert it. It makes sense. But the problem is this method is going to convert it into local time. So you need to make sure that you use the UTC from timestamp. Once again, be mindful of this. Be careful of which methods you're using. So some common use cases. The date time, so you've got a couple different things in the Python library. You've got the calendar, you've got the date time, you've got the time modules. What it means is it's all kind of really hard to work with. And there's a newer library called Arrow that I found to be just really fun and easy to work with. So that's what I'm going to recommend. This is an example of getting a time. This is also an example of trying to get a time. So Arrow is really good for automatically understanding kind of the ISO standard timestamp, but it's not so good when you try to use a different format. You can pass a second parameter to Arrow to get to tell it what format the time is in, but at least in my case, I like to give my users the ability to write the date however they want, rather than mandating a date to make it a little bit more user friendly. So I'd like a way to I'd like a more friendly way of getting user date time strings into real date times. Enter dateutils.parser, which is really pretty flexible, huh? I can tell it I want Tuesday, and it'll try to guess for me. Might be ambiguous, but if I'm getting input from the user, it is pretty flexible. I think out of all of the date time stuff, Arrow has the nicest API. We can get UTC time. It has a replace method so that we can go forward or backward in time. We can also just replace things. So be careful with UTC. Be careful with arrow.replace. Hours -1 shifts the time back, and hours equal 1 would shift the time forward an hour. Replace hour equals 1 would just switch the hour to 1. So plurals will get you here if you don't pay attention. It just allows you to really easily work with the time zone name without having to go actually get the time zone from PyTZ or dateutils, pass it to the date time object, do a replace. It's ridiculous. So it's just really nice API. The local, the timestamp humanize methods, those are available on any Arrow object, not just the local one. I just converted to local so that you could see how easy it was to get to local. Make sure that you are, or all I'm doing here is showing that you can go from that local time back to UTC, and that you have the same number basically. You also have all of the methods and attributes that are on the date time objects are also available on the Arrow objects. So we saw how to convert from user input. Now we saw some of the nice API in Arrow for dealing with conversions and making changes to the date time. So when we want to get it back out to the user, it's pretty easy. Once again, you can just do utc.to and give it the time zone, which hopefully you've stored somewhere, or maybe you're asking the user for it. And then it's, once again, really easy to format it. I'm pretty sure it's using the same formatting stuff that Python uses as far as the date time formatting strings. So the question here is, when I'm trying to give the time back to the user, how do I know what time zone they're in? If you're working in a web context, you can do date get time zone offset. Unfortunately, just because we have an offset doesn't mean we know the time zone. If you wanted to, you can combine that with some geolocation and try to guess the user's time zone. But everywhere I looked, people said that you should probably just ask them what time zone they're in. And then if you notice, so if I know somebody's in EST, and due to the browser or JavaScript, I detect that their offset is now -9. I could probably prompt them and say, do you still want to be in this time zone? Your offset looks wrong. This is what Google Maps does, or Google Calendar does. If you transfer time zones, it'll pop up and say, hey, do you want to change your time zone? Which I think is pretty cool. But they're Google, right? All right. I don't have much time for questions here, so I will be available outside if anybody wants to chat about this. Thank you.